Kia ora koutou, ko Tiffany Taku Ingoa, he kairuruku tauwhainga aho ki Manaki Whenua. Good morning everyone, my name is Tiffany and I am the Events Coordinator at Manaki Whenua Landcare Research. Before I hand over to Christine, I'm going to run through a couple of technical slides to ensure that your experience with us online today goes as smooth as possible. If you have joined us previously for a LINKOnline session, you can ignore me for the next minute. You will notice you have a control panel at the side of your screen. If at any time this collapses, you can bring it back by simply clicking the orange arrow button. If you're having sound issues and you can see my mouth moving but cannot hear a word I'm saying, please grab the PDF in the handout section, and this has instructions to resolve this quickly. The audio panel is where you can control where the sound plays on your computer. Select the drop-down arrow and choose your audio output. During the presentation, you may have questions that you want to be covered in our Q&A session. You can do this via the chat panel throughout our session today. You will notice it is pretty small and it will be hard to read other attendees' questions. Select the pop-out icon on this panel and drag the corner out to make it as big as you want. You can also use this feature if you're having technical issues and ask me any questions. Questions asked by the audience show as anonymous and a green colour in the chat panel. If I respond to you regarding a question, this will show as red. Now over to Christine to introduce you to our LINKOnline session.
Kia ora, thank you for joining us again today. It's great to be able to connect and share this information. We know there's a huge appetite for people to know more about LCDB, and we know that a lot of people are using it already in their work. I'm used to running these seminars in a room in Wellington, and I'd normally kind of ask for a show of hands on how many of you have already used version 5. So sitting at your desk, I can't see you, but hey, put your hand up. It's good to move. David Pearman is the research leader for our remote sensing group. He's going to talk for about 20 minutes. Now, we're a bit nervous. He's had 1 or 2 internet challenges in his street, so just bear with us. We'll keep the show on the road as best we can if there's any little hesitations along there. I would encourage you to put your questions in the questions box as soon as they occur to you. We'll sort those through and ask some questions of David at the end. Now I'm going to hand right over to David.
Okay, good morning. I'm David Pearman, Manaki Whenua's Remote Sensing Research Leader, and this morning I'll be talking about the recently released version 5 of the LCDB. It's not just my work, obviously. Peter Newsom led this program or project. He's recently retired from Landcare, but he had a team of mappers, Anne Sutherland, Michelle Barnes, Salabellis, working under him, and also people like James Shepherd and myself doing a lot of the data processing behind that, and others like John Diamond, Steve Campbell, James Barringer, Robbie Price, and probably others I haven't mentioned who all put in an effort to get this out in January. So I'll quickly run through what I'll be talking about, start with some brief details of the LCDB version 5.0, look at the changes from earlier versions. I'll then tell you where to get it and how to view it. There's a lot of ancillary information, useful information that goes alongside the LCDB, so I'll point some of that out, and also show you how to feed back errors in the LCDB and mistakes that you might come across. I'll focus on some of the change summaries, so that's pre-compiled analyses that have been done for the LCDB and you might find useful, and also then spend most of the talk going through some of the significant improvements that you'll find in version 5. I'll finish up by talking about some of the usage issues. So starting off with some brief details on LCDB, I kind of assuming that most people in the audience know what the land cover database is, but for those of you that don't, it is a land cover map of New Zealand. It's really scaled to have a minimum mapping unit of 1 hectare, and it has a classification at 5 different points in time. So I won't go into a lot of detail on the LCDB. I'm assuming that most people know about it, but this new version of the LCDB was funded on behalf of the government by the Ministry for the Environment, Te Uru Rakau, Ministry for Primary Industries, and the Department of Conservation. And it was publicly released in January, the end of January. But our funders, they actually had it since late last year, and we got a lot of good feedback from them through January and made some useful changes through January. It's fundamentally compatible with earlier versions. Obviously, we've added the new time step to represent the 2018-19 time period, but there are significant improvements across all time steps. So it's not just that new time step that's important here. We've done a lot of new mapping and a lot of improvements. It's the first revision that we've done using the new Sentinel, the European Sentinel-2 satellite constellation, and that gives us access to a lot more data than we've mapped from in the past. So in the past, where we might have used a single image to map from, now we have multiple images at different dates in the year, and that really helps us understand what the vegetation is. Earlier versions of the LCDB are now deprecated, so please don't use them. If you need to look at one of the earlier LCDB time steps, you don't need to go back to an earlier version of LCDB to get that time step. All of the time steps, that's 96, 2001, 2008, 2012, and 2018, they're all contained within LCDB version 5. And of course, it has been available for some time now, and people are actively downloading it and using it, as Christine mentioned. So what's changed in LCDB? Well, I guess obviously we've had to add some attributes to represent the new time step, which is normally 2018. So there's a couple of attributes for that. We've also changed the wet context attribute. This was an attribute that used to be a single attribute within the LCDB to represent a wetland context of classes that weren't obviously wetland. So that would be things like deciduous hardwoods, flaxlands, manuka kanuka, and gorse and broom. They could all exist in a wet context, basically a wetland, but they weren't obviously a wetland class. So they had that wet context flag. Now we have a wetland flag for each time step. And that allows us to change the wetland context between the time steps, and you can actually see when wetlands disappear and that sort of thing, which we couldn't really do in the past. So it's a lot more consistent. We have also applied that wetland flag to the obvious wetland classes. That would be herbaceous freshwater vegetation, saline vegetation, and mangroves, which it wasn't applied to in the past. And I'll just point out that rivers, lakes, and estuary and open waters aren't considered wetlands within the LCDB. So in this image, you can see an area that was herbaceous freshwater vegetation, quite a big area of it originally, and now at some point, a couple of cycles back, some of it got turned into a lake, some of it got turned into low producing pasture, and down in the bottom right there, there was an area that got turned into high producing pasture between 96 and 2001. So you can see how this wetland flag changes from yes to no, 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 and it's there for each time step now. Similarly, we've changed the onshore flag. Again, we used to just have one onshore flag for all time steps, and now we have an onshore flag for each of the time steps. It's not something that's used a lot. We basically set these onshore flags from LINS coastlines, and we wanted to use official LINS coastlines rather than try and map it from the imagery, which can be fraught. The LINS coastline that we used for the 2012 mapping was really just a snapshot at that time, because LINS update their coastlines as they revise map sheets. It's not an update for the whole country all at once. So it's really just a snapshot. And we took another snapshot for the current revision for 2019 or 2018 rather. And when you look at the differences between those, most of it's just improved mapping that LINS have done of the coastline, a lot more detail of the coastline. It follows more faithfully the coastline. And so that's not real change that we want to map. So we've only tried to introduce into the LCDB changes where there is actually real coastline change. The rest of it has been mapped in with the improved LINS coastline for all dates. But where it changes is where there's something significant, like this reclamation in Littleton Harbour, where it wasn't there before, so it would have been the onshore flag would have been switched off, and now it is switched on. There's not many examples throughout New Zealand of this. So it's of limited use for that, but it really saves us from some major discrepancies if we didn't introduce this notion of having a changeable coastline. I should point out that this is really just looking at big changes, significant big changes that would have been major discrepancy otherwise. So it's not a suitable method for tracking coastal movement on the fine scale. You wouldn't want to use this methodology. It's not suitable for tracking coastal erosion or something like that. So where to get the LCDB? You can pick it up if you're using a GIS and need the whole data set. You would pick it up from our lris.sciinfo.org.nz. That's our LRIS portal, and you can download it directly from there. If you don't want to use a GIS and you just want to look at the LCDB, then I would recommend using the LCDB Explorer, which is available from our environments.sciinfo.org.nz. Now that this is colours up the polygons and nicely, and it also shows the relative areas of different classes within the screen that you're looking at. So as you move around, those bars all change in length. The tool also allows you to do a little bit of change analysis. So you can set it up with this wee clock symbol to look at, in this case, exotic forests at the beginning of the time sequence, and then move the time sequence along to look at what that area of original exotic forest ended up as in 2018-19 summer. Conversely, you could set it up to look at an areas of exotic forests that are at that in that state now, and have a look by moving the time slider back to what classes contributed to that current area. So it's quite a handy tool to be able to quickly see what's happening in the New Zealand landscape. Another way of getting LCDB data is through our web mapping services. This is really for programmers who are developing a web application and want to include LCDB data in their web application. So they can pull it directly from our servers using the application programming interface. And we also have some experimental APIs for feature services, but you need to really contact us if you're interested in using that. So I'll go back to our portal now and just point out that there's a lot of ancillary information available. There's a few guides that go through some of the things I've already talked about. They probably make a better job of it, so I'd recommend that you download those PDFs and have a read of them. There's some files that give you good definitions of what the classes are, both text and a lot of photographic examples to illustrate what the classes actually mean. There's some symbology which the ARC users will find very useful, just to colour up the polygons, rather than just having the polygon outlines. We have a colour code that helps you interpret things. And the other thing I want to point out is this feedback button. Now this is really designed for you to feedback any errors that you find in the LCDB. It's really targeted at identifying individual polygons that are incorrect, and we would hope that you would follow that feedback button, and it allows you to enter maybe some additional information like photographic evidence, obviously a description of the problem and things like that. So that helps us to improve the LCDB in the future. But as I say, it's really sort of focused on individual polygons or local error. If you're finding that there's a more systematic error through the LCDB, or you want to offer up some data sets that might help improve future LCDBs, then it's probably better to contact us directly and discuss that rather than try and try and make the corrections through this feedback mechanism. But it is a formal mechanism, and it'll log a ticket for each error that's identified, and that gets dealt with as we revise the LCDB. I want to move on now to talk about some of the pre-analyzed summaries that we've done with the LCDB data, or from the LCDB data. And this is a bunch of Excel spreadsheets that look at transitions between the different time steps. So it's got all the classes down one side for one time step, and then along the top for another time step. And so, as I say, there are 4 of these Excel data sets for the differences between the different time steps. There's also a lot of tabs along the bottom, and this allows you to choose either the full country, stats for the full country, or for individual regions, including the Chatham Islands. So you can choose what you want here. And it's fairly simple, I guess, once you look at it, how this operates. You follow along a row to see what was a class in this instance 2012, and then look down the columns to see what it's turned into in 2018 in this case. So it's just a useful summary of all the statistics. Down the very right-hand column here, you can see the total losses for each of the 2012 classes, and along the bottom, under this new row, you can see the total gains for each of the classes in 2018. And if you take one away from the other, you'll get the net gains, which are also shown here, highlighted in green. Looking at some of the transitions here, is quite interesting. I've looked at all 4 of these in some detail, and you see quite a transition between some of the grassland classes, depleted grassland, tussock grassland, low producing grassland, and high producing grassland. There seems to be a trend of basically an intensification of grasslands throughout New Zealand as you look through the different time steps. Things get changed from a lower class grassland through to a more intensified grassland. The other thing I'll point out is some total statistics summaries at the bottom here. Only a small area of New Zealand has actually changed between these 2 time steps, 2012 and 2018. So it's less than 2% of the land area has changed. And when you look at what has changed, you see that 2/3 of that is actually a change in the production forestry cycle. So that's exotic forestry getting felled, turning into the forest harvested class, and vice versa, replanted. So quite a bit of it is maybe not of a lot of interest to you, but there are a lot of other quite interesting details going on in the changes between classes. We've also added the wetland flag in there, and you see that there's about 1,500 hectares of wetland lost between these 2 time steps, and that seems fairly consistent when you look at the other files as well. There's a gradual loss of wetland. So I'm going to whip through some of these other significant improvements that happened in LCDB version 5.0. First of all, looking at wetlands, we've done a lot of work incorporating data from other sources into the LCDB in this version. We've looked at the wetlands of national significance, the Woni wetlands. We've used information from an MFE study looking at wetland loss, and a number of the councils have provided wetland information in their region. So we've taken all that information and remapped it into the LCDB, and there's quite a lot of fine detail that wasn't there in version 4. You can see here all these little strands of what's basically deciduous hardwoods that are in a wetland context, and also some herbaceous freshwater vegetation, little strands of that. Some of them aren't all that obvious in the grassland in the colour coding used here, but there's quite a bit more detail in the wetlands, particularly in the Waikato. Another thing that we do is targeted change polygon detection. So this is the main way that we look for change within the LCDB, we start off by doing a multi-date segmentation. So we're looking for groups of pixels that segment the imagery based on groups of pixels that either look the same or change in the same way between the 2 dates. And it's that latter group, the ones that are changing in the same way, that are potentially changes in the LCDB classes. So we add additional, after doing the segmentation, we add additional attributes, for instance, radar attributes, DM generated attributes, and possibly others. And then we come up with a bunch of rules, and it will depend what the target polygons are that we're looking for as to what the rules are, but we can look at thresholds and base those rules to pick out things like destocking or restocking or scrub changes or urban changes or water body changes, and etc. So basically that's the methodology used. We try and identify the likely changes, and then we do a visual confirmation. We've got a fairly slick means of whipping through and visually looking at the imagery and confirming that it is something that should be mapped. And then it's passed to the mapping team to actually draw up the boundaries and incorporate it into the LCDB. A lot of this work was done for the MFE's land use mapping, which went up to between 2012 and 2016, so we made a lot of use of that. But of course, had to repeat some of all of this sort of work for the period between 2016 and 2018, which wasn't covered by the previous LUM work. Other significant changes to LCDB 5. There's an area of Stewart Island, quite a large area that in version 4 was mapped as herbaceous freshwater vegetation. That was simply wrong. I'm not sure if it got corrupted at some earlier version of LCDB, but it was certainly not accurate. And so that whole area has been remapped by hand. It's not an area that there's a lot of change going on in, so this mapping has been applied to all the time steps within LCDB. It's not just the latest time step. There's obviously herbaceous vegetation still there, but there's a lot of it is now mapped as Manuka, Kanuka, broad-leaved indigenous, this lighter tan, and there's also some tall tussock and some saline vegetation mapped in Patterson Inlet there. So quite an improvement in the Stewart Island mapping. In Christchurch, of course, we've had the earthquake, and post-earthquake, a lot of this, what was known as the red zone, got wiped out, the houses removed, and it's now mapped as urban parkland. So quite big changes in Christchurch. And you can also see around the periphery of Christchurch urbanisation going on. So that's fairly typical of the larger urban centres around New Zealand, that around the fringes there'll be growing urbanisation. But there's quite significant changes in Christchurch due to the earthquake results. Another thing that we did quite close to the end was just try and make some improvements where irrigation, there's an irrigation layer available from MFE, and we just wanted to check that where irrigation is happening over pasture or grasslands, that we actually have them down as high producing pasture, because once it's irrigated, it's going to be high producing. So we did run some checks at the end and actually made sure that all the areas that are irrigated are now noted or classified as high producing pasture rather than one of the other classes. So I can't, this is just to the west of Lake Tekapo, and I can't put my hand on heart and say that these irrigation circle polygons were as a result of that process. They could well have been picked up by our mappers earlier, but we've certainly tried to remove any inconsistencies. Other improvements were obviously feedback, known errors from users, and we also gave our mappers a couple of weeks of just freestyle scanning throughout their regions to try and pick up things that had slipped through the gaps of the more targeted changes that I've already talked about. Quality assurance, we try and look for all sorts of unexpected problems. So we're looking at significant areas that have changed in a region, or even just individual large polygons that have changed, and just look for unexpected changes. And we also look at improbable transitions. So you get things like, you wouldn't expect urban classes to be reclassified as either agricultural or forestry classes. So that would be an improbable transition. And also you don't expect exotic forestry going to indigenous forestry, although it does happen. So there's a whole bunch of improbable transitions that we look for, and just double check on that sort of thing. We had feedback, of course, I've mentioned, from our stakeholders and funders, and that was very useful throughout January, and we tried to incorporate as best we could any problems that they picked up on. So I just want to wind up by talking about some usage issues. Fundamentally, the LCDB is still a 1 hectare mapping scale. So it's designed to pick up broader scale patterns of change throughout New Zealand or regionally, but it's not going to pick up very small changes. So something significantly lower than a hectare is not going to get mapped. And if you are looking at a change that is inherently small areas, that can accumulate up to a large area, but it won't get picked up by the LCDB. And what I'm saying here is that LCDB fundamentally wouldn't be the correct data set for doing that sort of analysis. So you just have to bear in mind what LCDB is designed to do and try not to use it for something that it simply won't work for. So in summary, LCDB is out there, available now. Please use the new version. It's got the new 2018 time step, but there's really significant improvements throughout the LCDB applied to all time steps, better mapping in a lot of areas. There's a lot of additional information on the portal and some pre-compiled analyses that you could find very useful. Please feed us back any errors that you pick up on, and also if you have data sets that you feel could be usefully applied to future versions of LCDB, we're always interested to see those. So thank you for listening.
Hello again from Wellington. Thank you very much, David. That was a really, really interesting presentation. I think a lot of people have found it interesting, and I think they've also found that you've covered a lot of the questions already. And we've only kind of allowed a couple of minutes left.
Sorry, I've run over, have I?
It was great. It was so interesting. We couldn't stop you. So it was, you really were answering a lot of questions. So I want to, let everybody know that we will answer all of the questions that come in. Keep sending them. We may not be able to answer them all here on the show. I don't think we get chucked off at 11 o'clock. So we're going to just extend about 5 minutes and try and deal with a few questions. But rest assured, everything will get addressed in the long run. Laura and Jody were both asking quite early on some questions around wetlands and saline versus freshwater. Does LCDB really only cover freshwater wetlands, and how does it distinguish between those and coastal wetlands?
No, the wetlands, it covers both. There are some classes that are obviously saline, so mangroves, but there's other types of saline vegetation, and they would be around the coast. So there is a saline herbaceous vegetation class covering those. There's also a specific mangrove class, and then if you're talking about freshwater wetlands, there's a class called freshwater herbaceous vegetation, and there's a number of other classes that are often or can be found in a wetland context, but aren't so obvious. I mentioned some of those, like deciduous hardwood, flaxlands are often wetlands, and you can get manuka, kanuka, and there may be others. So it does cover both wetland and saline. You probably need a bit of biological knowledge to kind of understand where that might be occurring if it's not explicitly stated as being a saline or freshwater wetland. I hope that answers the question.
Thanks, David. No, that's great. I think there's lots of questions about wetlands, so we will take a look at and make sure that we cover that. Nancy from MFE has asked us, how good are the distinctions amongst the grassland types? Is high producing or low producing simply based on visual assessment?
It largely is, and it's an area that we're not entirely happy with. I haven't mentioned that there's a very active research program going on. Originally, when we were looking post-COVID at doing this seminar, we were going to have a longer seminar and include some of the research program in that, but that's going to have to be a separate issue now. But it's certainly an area that we're not happy with. We feel it's a weakness within LCDB. A lot of that has been visually interpreted, and we're looking at ways to try and make that more robust in future versions. So that's an active area of research, but it's certainly, I would say, a weakness in current LCDB.
That's great. There are one or two other questions here. This is a bit technical. I'm not sure if we can answer this, but let's give it a go. Someone has sort of made a comment that it would be nice to be able to download a spreadsheet with attribute data to do their own change analysis.
Yes.
Is that possible, or something you've thought of?
Yes, it is actually, and I did supply it to somebody who asked me back in January or February. So I can put that data up on the portal. It did occur to me that maybe other people would find that useful. So the change tables that I've got are basically, you know, pivot tables taken from data. Now you can do it yourself, obviously, if you have the GIS skills and whatnot to pull down the whole LCDB and generate that sort of information, but some people don't. So I think it's probably would be useful if I just put up the raw data that goes into those pivot tables so that people can cut it up in different ways. I think that's what you're asking there.
That's great, and we can elaborate and come back to you about that directly, Karen. One last question. Can we say more about appropriate usage for fine scale land use change?
Well, it's a difficulty because LCDB, you know, has been designed and has been funded in the past to work at a certain scale. To significantly improve that scale, say you wanted to go down to 1/10 of a hectare or something, it's a huge task. Quite a different approach to things, and yeah, I mean, we would have to look at how that could be done if there was a real push for it and how it could be funded. But the LCDB has really been designed to look at sort of national results and regional results, and so I guess you need to think what you're trying to do. If it's a smaller regional question that you've got, then it's probably more appropriate to be looking at doing some separate mapping at the appropriate scale in that smaller region. If there's some significant requirement out there to do national mapping at a really fine scale, then that's a bigger question that we would need to look at and figure out how to fund it.
Thanks, David. Look, I think we should finish there so that we can let everybody get back to their busy locked down lives. I'd like to say a big thank you to everyone for joining. I'd like to say a really big thank you to David for a fantastic presentation. You will get a link to the presentation so that you can review that again, and we'll also try and deal as quickly as we can with some of the questions and of course the answers to those questions. We've got another link seminar next week. They're coming in thick and fast at the moment. The next one will cover some of the results from the 2019 Survey of Rural Decision Makers. And you should particularly tune in if you're interested in forestry and tree planting. The invitation will appear in your inbox before too long. So I'd like to say thank you and goodbye from all of us at Manaaki Whenua.
Thank you for listening and goodbye.